Hello and welcome to Mathematical Coaching Center. Today in this video we'll be discussing a theorem related to angles in a circle. But before we start that, my name is Umang Khwas, and if you have any problem in learning mathematics, then consider subscribing this channel. So without any further delay, let's see the statement of the theorem. The statement states that the angle subtended by an arc of a circle at the center is double the angle subtended by it at any point on the remaining part of the circle. So suppose there's a circle with center O and there's an arc AB and we are making an angle at the center, that is angle AOB. Now we need to make one more angle at the remaining part of the circle. So we need to make the angle somewhere here. So we are making this angle ACB in the remaining part of the angle. So the angle subtended at the center, that is this angle here, will be double the angle that is subtended in the remaining part of the circle, that is the circumference. Okay, so but this will not be the only case here, only diagram that we get. So if we have this point, we can choose this point anywhere on the remaining part of the circle. So if we choose this point somewhere here, so we'll get a diagram somewhat like this. Okay, so this is the point C and this is the angle at the center and this will be angle at the circumference. Now again, if we choose the arc AB as the major arc and the point C is chosen somewhere here and we make the angle at the circumference, so this will be the angle at the circumference. So this is the third diagram that we get. So this will be three different cases here. So here this is the angle at the center and this is the angle at the circumference. Okay, so this is the angle at the center here and this is the angle at the circumference, and here this is the angle at the center and this is the angle at the circumference. Here we'll be writing angle AOB to represent the angle at the center. Okay, actually this angle AOB is the reflex angle AOB, but we will be representing it with angle AOB only. Okay, and there should be no confusion with it. So to prove this theorem, we must know very important result. Okay, let's see the two important result. So the first result says that the angles opposite to the equal side of an isosceles triangle are also equal. Suppose there's an isosceles triangle and where AB is equals to AC. Okay, these two sides are equal. So suppose here AB is equals to AC, then this angle ABC, that is opposite to AC and opposite to AB, that is angle ACB, will be equal. That is this angle here and this angle here will be equal. So this is the very important result of an isosceles triangle. So next result that we will be using to prove the theorem is that the exterior angle of a triangle is equal to the sum of the opposite interior angles. Suppose there is a triangle and we have an exterior angle. So this ABC is a triangle where BC is extended to the point D and we get an exterior angle here, that is angle ACD. So angle ACD is the exterior angle. So this will be equal to the sum of the opposite interior angle, that is the opposite interior angle is this angle here and this angle here. So that is angle ABC and angle BAC. So angle ABC and angle BC. So this angle ACD will be equal to angle ABC and angle BAC. So these are the two important results that we will be using while proving the theorem. So let us come back to our theorem. So this is the angle at the center and this is the angle at the circumference. Here in the second diagram, this is the angle at center and this is the angle at the circumference, and this is the angle at the center and this is the angle at the circumference. Okay, now let's see what we need to write in given. Here we see that this angle, this AB is an arc which subtends an angle AOB at the center. This is a circle with center O and angle ACB is the angle at the circumference, or this is the angle which is subtended by this arc on the remaining part of the circle. So this is the thing that we need to write in given. So given arc AB subtend an angle AOB, that is angle AOB here, at the center of a circle with center O, okay, and angle ACB is the angle at any point C on the remaining part of the circle. Angle ACB is any point in the remaining part of the circle. So this is the given that we write. Okay, now this is applicable to other diagrams also, that angle AOB is the angle at the center. Okay, that AB is the arc, and this arc subtends an angle AOB at the center, and C is any point on the remaining part of the circle, and this angle ACB is the angle at the circumference. And this is applicable to this third diagram also. Now let's see what we write in required to prove. Okay, so as the statement says that this angle should be double the angle at the circumference. That means angle AOB will be twice of angle ACB. So that is what we need to write in required to prove. So required to prove angle AOB is equals to 2 angle ACB. So twice angle ACB. So angle at the center is double the angle at the circumference. Okay. So now to prove this, whatever is given is not sufficient. So what we will do is we will construct a line. So let's see the construction. So in construction, what we will do is we'll join CO and we'll extend it to any point D. So we'll be joining this 2 points C and O, and we'll extend the line to some point D. So this is the line that we are drawing from C and O. Okay, joining C and O, and we'll extend this point till D. Now we'll also do the same thing on the two other diagrams that we have. We'll be joining C and O, and we'll be extending this till D. Here also we'll be joining C and O, and we'll be extending till D. Okay, now let's see the proof. So in proof, we will be taking two triangles. First, let's take triangle AOC. So triangle AOC in the first diagram is this, and triangle AOC in the second diagram is this, and triangle in the third diagram is this. Okay, triangle AOC. Now in that triangle, we can see that the two line segment OA and OC are equal. That means OA, this line, and this line OC are equal. Okay, and here also OA is equals to OC, and here also OA is equals to OC. These two lines are equal. And why is that so? Because they are the radii of the same circle. So this is the radius, and this also the radius. So both are the radii of the same circle. So that means they will be equal. Now this was a triangle that we are considering, triangle AOC, and the two sides are equal. That means it is an isosceles triangle. That means angle opposite to the equal sides are equal. So this angle here opposite to OA will be equal to this angle here opposite to OC. That means angle OCA will be equals to OAC. Here also opposite to this will be this angle here, and opposite to this will be this angle here. So that will be equal. Here also opposite to this OA will be this angle here, and opposite to this will be this angle here. So this is angle OCA, and this is angle OAC. Here also we have angle OCA and OAC. Here also we'll have angle OCA and angle OAC. So these angles are equal here. Now let's see one more angle, that is angle AOD. So if we make the angle AOD in the first diagram, this is the angle AOD. Now see, this is a triangle here, and angle AOD is the external angle. Okay, so this is the external angle. This is the triangle, and one of the sides is being extended, and we get an angle here, and this is the external angle. So here also this is the external angle, this is angle AOD, and here it is AOD. So this is the external angle. So from the second result that we know, the external angle is equal to the opposite internal angle. So this angle here will be equal to the sum of this angle and this angle here. So here also the same case, this angle here will be equal to the sum of these two angles, and this angle here will be equal to the sum of these two angles. Okay, so this will be equal to angle OCA plus angle OAC, And why is that so? It is because the exterior angle is equal to the sum of the opposite interior angle. And we know that angle OCA is equal to angle OAC. So we will be replacing OCA in place of OAC. So we'll be getting angle OCA plus angle OCA. Now adding OCA plus angle OCA, will be getting 2 angle OCA. So finally we get angle OAD is equals to 2 angle OCA. That means this angle here OAD is twice this angle here. This angle here is twice this angle here, and this angle here is twice this angle here. Okay, so half of the proof is done. Now we'll be seeing the next triangle. So we'll be considering triangle BOC. Now this is the triangle BOC in the first diagram, this is the triangle in the second diagram, and this is the triangle in the third diagram. Now here also we see that the line segment OB is equals to OC. OB is equals to OC. OB is equals to OC, and OB is equals to OC. And why is that so? Because it is the radii of the same circle, and that means it is a isosceles triangle. Again the same result, that the angle opposite to the equal sides are equal. So we have angle OCB. Angle OCB is equals to angle OBC. That means this angle OCB will be equal to angle OBC. Here also we have these two angles equal, and here also we have these two angles equal. Now we'll be considering the external angle as we considered before, the angle BOD. So this is the angle here. Okay, this is the external angle here. Here also we have this external angle, because this is the triangle, one of the side is extended, so this is the external angle here, and this is a triangle, and this is the line extended, so we have the external angle here. Here also we know that the exterior angle will be equal to the sum of the interior opposite angles. So this exterior angle will be equal to sum of these two angles here. This exterior angle here will be equal to these two interior angles here, and this exterior angle will again be equal to these two angles here. And it is because the exterior angle is equal to the sum of the opposite interior angle. Now we have that OCB is equals to OBC. So we'll be replacing OBC with angle OCB because both are equal. So we'll have angle OCB is plus angle OCB. Okay, so this will give us 2 angle OCB. So what is the value of angle BOD? The value of angle BOD is 2 angle OCB. The two important equations that we get is angle AOD is equals to 2 angle OCA, and angle BOD is equals to 2 angle OCB. So let's try to use this in the first diagram. So here we see the angle AOB. Here we will see the angle AOB. So this is angle AOB here. So here we can see that this angle, whole angle, is the sum of angle AOD, that is this angle here, and angle BOD. Okay, so angle AOB is the sum of angle AOD plus BOD. And what is the value of angle AOD? It is 2 angle OCA. And what is the value of angle BOD? It is 2 angle OCB. Now taking out 2 common, we'll have angle OCA plus angle OCB. Now let's see where is angle OCA. OCA is this angle here. Okay, this angle here, and angle OCB is this angle here. Okay, so when we add this two angle, we'll be getting angle ACB. Okay, so this is the whole angle that we get here. So finally what we get is angle AOB is equals to 2 angle ACB. So this is from the first diagram. Let's see from the second diagram. Again we know that angle AOD is equals to 2 angle OCA, and BOD is equals to 2 angle OCB. Now let's see what is angle AOB. So angle AOB is this angle here. Okay. Now this is the difference between BOD and AOD. So BOD is this whole angle here. Okay. BOD is this whole angle here, and AOD is this small angle here. Okay, from here to here. So if we subtract this part from the whole angle BOD, will be getting the remaining part angle AOB. Okay, so we are doing the same thing here. Okay, with that angle AOB is the difference of BOD and AOB. Now we know that the value of BOD is 2 angle OCB and AOD is 2 angle OCA. So taking out 2 common, we'll have 2 angle OCB minus OCA. Now let's see where is OCB. OCB is this angle here, this whole angle here, and OAC is this smaller part angle here. So when we subtract this part, okay, when we take out angle OCA, we'll be getting the remaining part, that is angle ACB, that is this angle here. Okay, so what is the final thing that we get? We get angle AOB is twice angle ACB. Okay. And finally, from the third diagram, you also will do as we did in the first diagram, that angle AOB is the sum of angle AOD and BOD. So this is AOD and BOD. Putting the values of AOD and BOD, we have this. So taking out 2 common, we'll have angle OCA plus angle OCB, and angle OCA is this angle here, and OCB is this angle here. And what is the sum of these 2 angles? It is angle ACB. So twice angle ACB. So finally what we'll get is angle AOB is equals to twice angle ACB. So from the 3 diagrams that we had, we get angle AOB is twice angle ACB. So this is how we prove this theorem. I hope that this video was helpful for you in understanding this theorem. So to stay updated, subscribe to the channel and turn on the notification bell. Thank you for watching and have a very good day.